Alright, so this is the engine comparison video. I'm going to be talking about the Pratt & Whitney PW1100G and the General Electric F110 129. So starting out with the Pratt & Whitney, the PW1100G, it's a high bypass 12-to-1 ratio. It's a geared turbofan, so what makes it the geared special and different from a regular turbofan is that it allows the compressor and the fan to operate at different RPMs, which maximizes efficiency, bypass ratio, fuel efficiency, and it allows the fan to be larger than the core section of the engine itself. So it's got a 3-stage low pressure compressor and a 6-stage high pressure compressor, both being operated by the turbines. The combustion chamber is an annular design. It's got reverse flow, and it obviously produces the high temperature, high pressure gas for the turbine section of the engine. It's a standard ignition, spark igniters, one source, continuous. And the turbine section, so it's got a 2-stage high pressure turbine and a 1-stage low pressure turbine. The accessory drive includes fuel pump, oil pump, electrical generator, and then let's see. The power output, so it produces 24,000 to 35,000 pounds of static thrust. The fuel burn is 0.51 pounds of fuel per hour per pound of thrust, and it's used on the A320 Neo. Let's see, now I got the General Electric, the F110 129. So the F110 129, it's got a square intake, 3-stage fan, which is used to direct the airflow to the compressor, which is a multi-stage axial compressor. The compressor has, it's a 9-stage compressor, which is driven by the turbine, low and high pressure compressor. Combustion chamber, it's an annular design, again, pretty standard ignition system, single spark, continuous source. The turbine, it's got a high and low pressure turbine, which are used to extract the energy from the combustion chamber, and the high pressure turbine drives the compressor, low pressure turbine drives the fan. Again, pretty standard accessory drive, hydraulic pumps, generators, fuel. And the power output, it produces 17,000 pounds of thrust on intermediate power and 29 to 32,000 during the afterburner, which is something I forgot to mention. That's what's another special thing about this engine, is that it has an afterburner section, allowing it to kick into higher power settings when necessary. It's got 1.9 pounds of fuel per hour per pound of thrust, and it's used on the F15 and the F16. So the main differences between these two engines, the biggest, I would say, well, first of all, they're both turbofans, so they're the same type of engine. But the biggest difference is the bypass ratio. The bypass ratio for the Pratt & Whitney is upwards of 10, and it's about 1 or sometimes even below 1 for the F110. One's used obviously for fuel efficiency on airliners, and one is used for power output on fighter jets. And then along with the efficiency of the engine, the fuel burn on the F110 is more than 3 times higher than that on the Pratt & Whitney. Again, it just comes down to the design. What are they looking for? One's looking for fuel efficiency, one is looking for power output. That's about it.